All right, we are on a new chapter. Page 216 is Chapter 6, Energy and Weather. So we've learned a whole bunch about how the sun's energy comes into the earth. Now we're going to learn about how that energy affects the weather. Lesson 1, to predict the weather, scientists study air temperature, humidity, air pressure, and other conditions. What kinds of changes can take place in Earth's atmosphere? Lesson 2, some of Earth's waters are warm, others are quite cold. Ocean waters are always moving. How do ocean currents affect weather across the planet? Lesson 3. On any given day, the weather can vary widely in different parts of California. What types of climate and weather are found here? Okay, let's flip all the way forward to page 222. We're on the lesson 1, called Weather. Okay, on your paper you need to write your name, AVID 6, today's date, Science FNT, Chapter 6, Lesson 1. Remind yourself what page it is, page 222, and the title of the lesson, Weather. Copy the main idea exactly from the book. Differences in air pressure, heat, air movement, and humidity cause changes in the weather. Differences in air pressure, heat, air movement, and humidity cause changes in the weather. Okay, go through and do your vocabulary. Air mass, page 226. So I flip forward, look for air mass. An air mass is a large body of air that has similar temperature and moisture characteristics throughout. Large body air, similar temp period for temperature and moisture. Air pressure, page 222. There it is. Air pressure is exerted by the weight of the air, pushing on all surfaces it touches. So air pressure, weight of air, pushing on surfaces. Condensation, page 225. Condensation, there it is. Condensation is the process that changes a gas into a liquid. Condensation, gas changes into a liquid. Dew point, page 225. Dew point, there it is. The temperature at which the air is saturated with water vapor is called the dew point. Dew point, temp for temperature, at which air saturated with water vapor. Basically, that means the air cannot hold any more water vapor, and if more water tries to come into that system, you'll start getting precipitation or rain. All right, evaporation. Evaporation, there it is. Evaporation is a process that changes a liquid into a gas. Evaporation, liquid into a gas. Next up, front, page 227. Front. A front is the boundary between two air masses with different temperature and moisture characteristics. So the front, boundary between air masses. Okay, looking at the weather map, it's going to be those lines. Humidity, page 225. 225, humidity. Go backwards. The amount of water vapor in the atmosphere at a given time and place is called humidity. So humidity, amount of water vapor in atmo, period, for atmosphere. Isobar, page 223. Isobar. Lines called isobars are drawn on the map to connect points that have equal air pressure. So those lines are isobars, and that means that along that line, it has the same air pressure. Kind of reminds us of the contour lines for elevation, doesn't it? Looks very similar. Isobar, lines on map, connect equal air pressure. Precipitation, 225. There it is. Precipitation includes the rain, snow, sleet, and hail that falls from clouds to Earth's surface. So rainwater, snow flakes, sleet is kind of halfway in between that mushy stuff, and then hail, like hard bits of ice that falls from clouds to Earth's surface. Rain, zoop, snow, zoop, sleet, zoop, hail, falls from clouds. All right, now we can start air pressure. Your red pen, air pressure. Nitrogen gas makes up about 78% of Earth's atmosphere, and oxygen makes up about 21%. The remaining 1% is mostly water vapor, argon, carbon dioxide, neon, and helium. Without the atmosphere, Earth would not have weather. So, nitrogen 78%, oxygen 21%, water vapor plus others 1%. I guess we should put CO2 there also because that's one of the super important ones we've been talking about. Atmosphere, aero, weather. The atmosphere helps us have weather. Without the atmosphere, we would not have weather. Air is matter. It has mass and takes up space. Air also has weight because Earth's gravity pulls the molecules of air towards its surface. Air pressure is exerted by the weight of the air, pushing on all surfaces it touches. Okay? Air has mass, zoop, takes up space, zoop, weight. That weight causes air pressure. So that's why I put a little arrow going to the air pressure. Air pressure decreases with altitude. So, altitude up equals air pressure down. You can add the equal sign in front of air pressure, add altitude up in front of that, and a down arrow after the air pressure. As you go up in altitude, you go down in air pressure. Okay, that makes sense. The closer you are to the surface of the Earth, the more air pressure you have because there's more atmosphere pushing down on you, stacked up above you. As you climb a mountain or go into outer space, you have lower air pressure because there's less matter or less mass pushing down on you. Temperature also affects air pressure. Warm air is less dense and exerts less pressure than cold air. Okay, that's the same thing we just learned in the previous lesson. Warm air is less dense. It can float or rise. That means it's exerting less pressure than cold air. Okay, warm air equals less dense. Arrow, down pressure. So if warm air is less dense, that means that it's lower pressure compared to cold air. All right, winds. A new section with winds. Winds can blow strongly or weakly and in many different directions. In all cases, winds form from differences in air pressure. These differences are caused by uneven heating of Earth's surface by energy from the sun. So, the previous lesson we learned about all that uneven heating. Now we learn that that's where the winds come from. So, different air pressure, arrow, wind. Differences in air pressure because of uneven heating are what causes wind. Oh, uneven heating causes differences in air pressure, which cause the winds. It's like a chain of events, kind of like our sequence of events in our flow map. Uneven heating causes differences in air pressure, and that causes the winds. The sun does not heat Earth's atmosphere directly. Instead, the surface is heated. Then that energy is conducted to the atmosphere. As a result, air is warm above a warm surface and cold above a cold surface. Air pressure is different too. Air pressure is lower above a warm surface than above a cold one. So again, you have a warm surface, you get warm air. That warm air expands and becomes less dense. It's less heavy, less weight, less air pressure. It rises. If we go back to the previous lesson, that's what causes the convection currents, the sea breezes and the land breezes. Air tends to move from centers of high pressure to centers of low pressure. This movement of air is wind. The greater the pressure difference is between the two centers, the stronger the wind. Okay, so high pressure, arrow, wind, low pressure. Wind moves from high pressure to low pressure. Makes sense, right? If something is pushing down harder, it's going to push into the weaker area. On a weather map, centers of high pressure are indicated by a blue H. Where is it? There's one. And centers of low pressure are indicated by a red L. Notice that blue H, that's the colder air, so it's blue. The red L is the warmer air, that's why it's red. So they're color coding the temperature. The high pressure is cold blue, the low pressure is warm red. Lines called isobars are drawn on the map to connect points that have equal air pressure. Isobars also provide information about wind speed. The closer together the isobars are packed, the greater the wind speed will be. Okay, so looking at this map, these lines that are really close together, it is going to be very windy, lots of fast wind here. These areas where the bars are really far apart, just a little bit of a soft breeze. So, high pressure, color code it blue, that's cold. Low pressure, color code it red, that's warm. All right, let's look at our graphs and diagrams. Air pressure is all around. Air pushes on all surfaces it comes into contact with. So you just sitting here watching this video, you have air pressure pushing all on you. It's just so light and we're so used to it that we don't notice it. Okay, air pressure versus altitude. I see altitude in kilometers and you're going up. Pressure in millibars going up. So let's see here. As you go higher in altitude, you have lower pressure. As you go down in altitude, like down to the surface of the earth, the pressure becomes greater. And I think that makes more sense. Like if you're standing way up here at the top of Mount Everest, there is very little atmosphere above you to push down on you, so the pressure is very low. You're almost into outer space. But if you come down to the surface, and maybe even all the way down here to Death Valley at sea level, you have a lot more atmosphere pushing down on you, so your air pressure is higher. Okay, isobars and the letters H and L show air pressure systems. Isobars are usually labeled with air pressure in millibars. Winds are strongest where the isobars are closest together. So, close together isobars, strong wind. Far apart isobars, weak wind, or just a gentle breeze. Red L is low pressure. Blue H is high pressure. The blue is for cold and the red is for warm. Air tends to move from high pressure towards low pressure. So looking at this map, you're going to have a lot of strong winds up here blowing out into the Midwest and down into the eastern states. Chicago, Illinois is right in this area. This is why Chicago is called the Windy City, because there's so much strong wind there all the time. They even tell us strong winds, weak winds. A windy day in California. Interesting. Looking at this little picture, it's not flat. I see hills. So I bet that helps cause uneven heating. That helps affect the winds. And the mountains and the hills probably channel the winds, making them even stronger coming through a little narrow area where those kids are. So they can come fly their kites. All right, main idea and details. What is air pressure? Okay, air pressure is defined as the weight of air pushing on all surfaces. Air pressure is basically a number that tells you how much atmosphere you have, but also it can tell you things like temperature, and it can help reveal uneven heating, right? So air pressure is because air has mass and takes up space, so it has a weight. Air pressure has to do with altitude and atmosphere. The higher you go in altitude, the lower air pressure you have because there's less atmosphere pushing down on you. Air pressure is also affected by temperature. If you have warm air, it's less dense, so there's less pressure. And then that air pressure, whenever there's differences, you get wind. The cold, high pressure areas tend to blow wind towards the low, warm pressure areas. All right, good job persevering. Growth mindset, roar Wildcats.